sound, and transition, and wave. Hello, everyone. How are you doing, Mama?
Doing all right. How are you this evening?
Doing all right. Anything exciting you've been up to since last time?
Not really. I took an hour off of work today.
Nice. Just an hour?
Well, just an hour because yesterday I mowed after I got home from work.
Mm-hmm.
I had
And then
to
it rained?
I had to stop before I got done because I ran out of gas.
Oh.
I had no go-go juice so I took an hour off today so I could go fill my little portable gas tank for the
Mm.
lawnmower and finish that last little bit and still have time to, eat I didn't shower because I was having to cool down, but after having mowed. But
Mm.
so I'll have to shower later, but I now have a fully mowed lawn, so
Nice. Hopefully it doesn't rain and all of the stuff that you cut grows right back. That would be annoying.
well, it will still all grow back and that's really annoying, but
That's true. Nothing that can be done about the Sisyphean task. Is that the right expression? That is mowing
yeah,
and all of the other chores that have to be done around a house.
every single time, dishes every day,
Yeah.
laundry.
Dishes are the worst. Laundry's at least you put it in the machine and you hit play and then you can walk away or sit down for a little bit. But dishes, you have to, unless you can use a dishwasher, you have to stand over them. And then there are
Well,
dishes that you
and
can't. Go
I
ahead,
have
sorry.
gotten into the habit of like breakfast. And that I've had the habit of for a long time. I plate my omelet, I wash the pan.
Mm,
I finish my breakfast, I wash the plate. Once I dump the eggs into the pan, I wash that bowl. So it's done before I leave for work.
mm,
And then like dinner dishes, I do those right away. So it's taken care of right away.
yeah. Unfortunately, I don't have the time to take care of um, my dishes right away, so unfortunately, I let them pile up, which then makes them take more time. So
Uh-huh.
I need to figure out a better system. It's I don't know. There was one point in time where I was actually decent at doing the dishes regularly, but the depression hits, and then it's difficult to do them, and then it's even more difficult to do them. Oh well, one day. Um, let's see. Is there a way that we can hit a happier note before
Sudoku.
Sudoku? There is Sudoku. That's the only thing I have, so let's hop over there. Now, we had a puzzle request from Michael Lefkowitz, or also known as Juggler, to tackle
Yep.
this puzzle. So we are going to tackle Crop Cominos first. So, Crop Cominos by Michael Lefkowitz. Fill the grid with digits from 1 through 8 so that no digit repeats in a row column or cropcomino. Within a cropcomino, orthogonally adjacent digits are always consecutive or in a 2-to-1 ratio, or both. All right. I wonder if this is a negative constraint. Well, not necessarily. I do kind of wish there was a grid. I wonder if taking rid of that gives me a grid back. Okay, yeah, I got a grid back. 1 through 8. And everything has to be... Well... So I guess I should think about things like the digit 7 and the digit 5. Because 7 has to be next to 6 or 8. Or, well...
Right.
It would have to be next to both of them, actually, wouldn't it? Well, I guess we know that things like these two have to be those two.
Yeah.
Kind of want to say that those 4 have to be those 4, but I don't know if that's as useful as those two being those two.
Yeah.
I'll leave it marked since I marked it.
Well, because, yeah, I made that observation as well, and it's like, yeah, maybe.
Yeah. Okay, well, 1 can only pair with 2.
Right.
Okay, well, that's easy enough. So if we look at the ones that are of size 8, well, that's not of size 8. Then we know a 1 has to go in there. This one's of size 8, 3, 4, 5, 6, 7, so that doesn't have to have a 1. 1, 2, 3, 4, 5, 6, that doesn't have to have a 1. Although I should have been able to tell that that was an 8, because there's only 1 here and there's 3 down there. So I think it's just these 3 that have to have all the digits. And we know that anything that has at least 2 neighbors doesn't work.
Right.
So those are our 1s in those regions. Which, doesn't force these, but...
Well...
This one can't be because of those 2. This is of size 4. This way.
Okay, if you look at the 2 on the right hand. Okay, if the one at the bottom that has blue in it, if the 1 is at the top, then where is it in the shape just to the crop common just to the left? It's right there. And if it's the one that's in blue, then the other one has to be up at the top. So, oh, that's still 3 spots though.
Yeah, it means one of those is required.
Yeah.
And one of those 2 is required. But we can still have it be one of those. And then you can put a 1 in here. I guess if there's a 1 in here, it has to be here. Because it can't go there, and those 2 have 2 neighbors. So they couldn't be it either. So... in these 2 rows, these are the only places a 1 can go. And well, 1 would have to be next to 2. And if 2 is already next to 1, then its next neighbor must be a 3 or a 4. Or in this case, a 3 and a 4.
Okay. Column 1, if the 1 is at the bottom, then looking along row 8. Row 8, you cannot have a 1 in row. The 1's already taken, and you can't have a 2 in row 7. So that doesn't work because that would break.
So then in this row, because we know 1 is removed from these positions because they have too many neighbors, and because
Right.
the 1 has to be one of these two, has to be here, our 1-2 pair has to be one of these two.
Uh-huh.
So if this was 1-2, and that's 1-2, otherwise we get 1-2 and 1-2. But it would have to look like this. Okay, well, we don't know if this is 3 or 4, though.
Okay, so if that red is 1 and 2, then the 1 and 2 are at the top of column 1.
A 3 here would put 4 and 6 next to it. And a 4 would put 5 and 8. So that's fine in
Or
either
3 could
way.
be one of them.
That's true. It would be 3, 5, or 8.
Okay, so look at in column 3 and row 6. That row 6, column 3, that spot has 3 neighbors.
Yeah. So what all has more than 3 neighbors? 1 clearly
Well, 2
doesn't.
has 1, 3, and 4.
Right.
3 has 2, 4, 6. 4 has 2, 3, 5, and 8.
I mean, everything has 2 neighbors except for 1 and 8. And
Right.
then it would have to be the stuff that can be doubled
Well, 8.
or halved.
Oh yeah, 8 just has 7 and 4.
Yeah. So anything that has 3 neighbors has to be 2, 3, 4, or 6. Because 5 and 7 are eliminated because they can't be doubled, nor can they be halved.
Right.
Um, 2, 3, 4, 6.
Go down one
That
spot,
2, 3,
that
4,
one.
6.
Oh yeah, I guess both of those do have 2.
2, 3, 4, 6. Did I miss anything else that has more than 2 neighbors?
I don't think so.
Yeah, that's all of them. But we know in this one that you can't put a 2 there. And actually, well, you could put a 6. We just know you can't put a 2 because the 1 has to be in the corner, which is immediately followed by 2. And this is true over here as well. This can't be a 2. Neither can this one. YouTube's upset.
Three's neighbors are 2, 4, and 6. So the 2 that are diagonal, rows and columns 7 and 8, the other way that are numbered, those can't be 3 and 6.
Right. So a 4 is required.
Gonna have to be a 4. Yeah. And 4 and 6 have in common a 5, but then the other one wouldn't work. Oh, the 3 would. 3's gonna have to be one of those 2. I think.
Because 4's neighbors would have to be 3, 5.
Right.
Which is the only neighbors that can put next to 4. So yeah, that's going to eliminate 3.
But you can put 2. Oh no, because 3 can go with 4 and 6. 3. If 3 and 4 are on the diagonals. 2. Yeah, because nothing else would go with the 3 and this 4. So yeah, that has to be that way.
Yeah, because we put a 4 here. We know 2 is there, so then then 2 neighbors of the 4 have to be 3, 5.
Right.
So then that would force the 6 here, because you can't put 6 next to 4.
Right.
So then, if this was 1, 2, and then we'd have 3 or 4, well, we know this would be a 1, 2, and 4. Well, hold on. The same thing's going to be true over here in this little box, isn't it?
Well, and that pair can't be 4, 6, because 4 and 6 aren't consecutive or in a 2 to 1.
Right.
So it's either going to be 3, 4 or 3, 6. So a 3 is required in that domino.
Okay, and if the 3 is required, if I put the 3 here, we already have 2 as a neighbor, so we have to put 4 and 6 as the neighbor. So then, well, in the other direction it would be 4, 6. And then the 4 is going to have, well, 5 or 8.
But to connect to the 6, it'll have to be a 5 with the 4.
Yeah. So if I did a 3, and then, so I did 1, 2, 3, and then this is 4, 6.
Right, and between 4, 6 has to be 5.
Right, because it doesn't really matter which way I go.
Well, except now we have 7 and 8 left.
Right. Which it's probably going to be 7, 8, 4, 6, and 5. Because 6 has to pair with... Well, no, because
No, because go the other direction. If it's 1, 2, 3.
7, 8. 6, 7, 8.
Right, but look at the superscript. If you go 1, 2, 3.
Then put 4, 6.
Right.
This is 4, 6, and a 5. And then
And 6 goes to 7.
8, 7, 8.
And column 7 now has a 3, 4, 5, 6 quad.
And this one just simply has to be 3. And the setup, that is 1 and 2 and
1, 2,
7, 8.
7, 8. Yeah.
Which we can put the 1 and the 2 separated like that, or the 7, 8 and the 7, 8 there, or 1 and 2 and 7, 8 the other way. Okay, well that was less than
Okay, and we know we've got a 5 and a...
Oh, well this has to be a 4, 6. That can't be 1.
5 is missing from that row.
Well, this one couldn't be a 5.
Right.
But that could be next to 4 or 6. Ah, but if that was 5, then how would it be consecutive with this one? Right? There's no
Right,
4 or 6. So 5 is out. So 1, 2, 7, 8 places a 5. Um, 2 or 3, 3 or 7.
Oh, never mind.
7 would have to pair with 8. 4, 3, 2, or 4, 2, 1, or 3. If I'm reading that correctly. Hold on. If this is a 6, 6 pairs with 5, 7, and 3. Oh, we already know there's no 5, so that's 3 or 7. A 7 would pair with an 8. A 3 would pair with 2 or 4. Because we already used a 6. So if this was a 4, 4 pairs with 3, 5, 2, and 8. So 5 is out. 8 pairs with 7. 3 pairs with 4, 5, or 6. But we already used 5, and we already used 4.
3 pair with 5.
Gosh darn it. 2, 4, or 6. 4 we've already used. 6 we haven't. And 2 pairs with 1 or 3, or 4. We've already used 4. So then that's 1, 2, 3, 6, or 7.
Now go up to the red that's next to the 4, 6.
Uh-huh.
You can't have 1 on the left because it can't pair with 1 or 6. Or
Right.
4 or 6.
And so you can't have 2 on the right.
Right.
For the same, they can't pair with, you can't pair with 2 or 7 or 8. So now this is either a 7-8 pair, which it could go 6, 7, 8, or it could go 4, 8, 7, or we can go 1, 2, 4.
Right.
Okay. Let me bring the 6 down. 3 and 7 down. 2, 4, and 8.
Well, now row 8 has a 4, 6 pair.
6 are out. Well, I guess we know what's on the other sides of these two.
Okay, so in row 8, the second cell,
This one.
if that's a 3, it has to go to 2, going to the right.
Yeah, and then a 4.
Okay. 2, 3, 4. Okay, yeah, it works. Never mind.
One, 2, 3, 7, 8. Okay. Yeah. 2, 3, 7, 8 are what these two are, right? Because consecutive is 3, 5, and 7. I guess you could put a 5 on the top. But you can't put it on the bottom. 6 divides in half to 3, and 4 divides in half to be 2, and doubles to be 8. So I think that's all of the options covered there. Well, if this was 1, 2, we would have to get 4 or 6 here. Which actually, we know that neither of those is 2 because of the 1, 2 up here. But if this was 1, 2, you'd have 3 or 4. Let me get rid of those. So then this couldn't be a 7, but it could be 3, 5, or 8. Ah, but how would this work as a 3? Because 3's neighbors are 2 and 4, and it doubles to be 6. But I can't put a 6 here.
Right.
And I cannot put
Put
2...
anything there that can connect to a 3.
Right. So this would have to go 1, 2, 4. But 3
6.
and 5 connect to 6.
Yeah.
Which would be 7, 8. So yeah, it would go 1, 2, 4, 5, 6, 3, 7, 8.
Yeah.
Otherwise, it goes 1, 2, 4. Which would be surrounded by... Well, you couldn't have 7 as a neighbor. You could have 3, 5, or 8. Now, 3 would already have the neighbors 2 and 4 removed. So this would have to be a 6. 6 would then have to connect to 5 or 7. 5 has already used both of its neighbors 4 and 6. That would have to be a 7 and an 8. And make that a 3. 1, 2, 4, 3, 6, 7, 8. Oh, well, that's 3 and 8, so I couldn't use 3. What number am I missing? 5. So I'd have to use a 5 up here, but I didn't use a 5 if I say this is a 3. But I could make it a... so that isn't a 3. But 5 would give me 6, 7, 8.
Right. And that becomes a 3 at the bottom either way.
Yeah. So this is just simply a 3 then.
Yeah.
Because it doesn't matter, because if this is a 5, that's an 8, which makes that a 3, or this is an 8, which makes it a 3. So if this goes 4, 8, 7, 6, 5. 1, 2, 4, 6, 7, and 8.
So then red is 1, 2, 7, 8. Okay,
Okay.
the blue.
Okay, I want to do that. 7.
Okay.
Blue. Well, this kind of has to go in a line.
Right. Well, 3 has to be up there
Yeah.
in the blue. And it's either with 1, 2, 4 or 6, 7, 8. If it's with 6, 7, 8, it has to be on one of the ends.
Mm-hmm. But it could go 1, 2, 3, 4.
Right. So that doesn't actually help either.
Yeah. It'd still have to have a 1 and then a 2, and then it's a 3 or a 4 in either order.
Well, no, if blue was 6, 7, 8, then the 3 has to be at the end.
Yeah. But if it was 1, 2, and then you can have the 3 or the 4
Right.
in either order. So you can put a 3 here or there. So the 3 can go in any of the 4 positions. So that's upsetting. If this is a 1, that's a 1. If that's a 2, that's a 2. 6, 7, but if that goes 1, 2, then this is 3 or 4. Hmm. Well, we know 1 and 8 is used up in the row, although I don't know how useful that is. Because neither 1 or 8 can... Well, it just can't go there. 1 can't go there, it only has one neighbor, the 2.
Oh.
Oh?
Well, in that row,
Yeah.
since the end is 1 or 8, then the
Yeah.
first 2 of the other is either 1, 2 or 7, 8.
Yeah.
Oh, never mind. You've already said that 1 and 8 are both used up. Never
Yeah. I was kind of hoping you'd spotted something farther
No.
than that one, because I couldn't see it, but unfortunately it wasn't the 7, because if it was the 7, that would take the 7 possibility out of there.
Right.
But, I think still
No,
6 would exist. And struggling to see how, like, let's say this one or that one was a 6. Like, well, I can't put 4 and 6 next to each other. So, because wherever I put a 3, it goes 4, 6, and then 5. Which has 4, 6.
All right. Well,
So,
let's look at row 6. That 2, 3, 4, 6. That has to have 3 neighbors.
yeah.
If that's a 2.
Mm-hmm. Let me get one on one of the sides. A 3 as one of the positions. And then lastly a 4. 1, 3, 4.
Okay, so if that's 2, then at the end of the row is a 7.
Right.
And the 8 makes that a 1, 2. And that's a 3 or 4.
3, 4 pair would force this to be 6, 7.
Yeah, that's not really helping any. Okay. I was just trying to see if one of them would at least help cut something down. So the
Yeah.
2 isn't helpful. If it was 3,
3 pairs with 2 and 4
2,
and
4,
doubles to
and
be
6.
6. Well, 2, 3, 4, and 6 would place a 5.
And an 8. And a 7.
And then 1. Which actually, we already know that 1 is either here or there. And the only way this is a
Right.
1 is if this was a 2.
Right.
Interesting. So, if this was the 1 making this a 2, then that's a 7, an 8, and then 1, 2. But if this is a 1, then that's not a 1, and that's 1, 2. So, this can't be a 1, because if this is 1 of those, then that makes that a 2, 7, 8, 1, 2. So
Right.
it doesn't matter. This is 1, that's 2. Uh, 8, 7, 6, 4, 2, 1. 6, not 6, not 4.
And that's no longer a 1 in the single.
Huh. 1, 2, 4, 6, 7,
No,
not a 6, 5, 6, 3, 4.
it's a 3 above the 2, not a 6. Column 3.
Oh, hold on, I messed all of that up. Because, well, that's definitely a 1. This is 3 or 4. Okay. But that can't be a 6, so since that can't be a 6, none of that is 1, 2, 4. 1, 2, 2, 7, 8. 5, 6, 8.
Well, in row 7, the 7, 8,
It only
3
worked if that
can't
was a
come off of that.
6.
It's got to be a 4.
Uh, 6 and 5. Just not a 1 in the middle and not a 2 on the ends. Okay.
All right. Column 5.
2, 4, 6, 5, 7, 3, 7, 6, 8, 8. 7, 8, 7, 8. 4 is out, 3 is out. 1 goes out. And you wanted to talk about column 5.
Right. It's left with, well,
With that. Get an 8
yeah.
in there.
So it'd be 3, 4, 8 or 5, 4, 8.
Well, we don't have the 7, so the 8 can't go in the middle, so that's 4. And all of those work?
Right. Yeah.
Well, 3 or 5 would be 2, 4, or 6. And that's it? Because
That's
3 is 2 or 4 because of neighbors, or 6
And
doubled.
6. Right.
And then 5 is only 4 or 6. There's no doubling or halving. So it has to be a 6 regardless because of the 2 and 4 down here.
1, 5,
5,
and 7.
7.
Well, okay.
Oh, well, this
That
is 2, 4,
column,
6 on the other side. 4.
yeah.
So 3, 5, 2, or 8. 3 and 5 is out. So that's 2 or 8. 8 would have to pair with 7, which it can't. So that's a 2, which pairs with 1 or 3. I don't know why I'm overthinking how to do these last 4, so I'm just going to go by
Column
row.
3 is 5 and 6.
6 and 5. And then
7.
8. Hey, it was an 8, I guess. Alright. That was a pretty fun puzzle. Solution code is row 4. So I should put it down here, since that's what's visible. That was kind of tricky. I don't think the start of that was easy at all. Because we kind of had to look pretty far ahead. I mean, maybe there was an easier way, but the path that we took, we had to think pretty far ahead in order to make progress. So, I guess there's a part of me that wants to go with... I don't know if it's hard. But, I mean, maybe? Because thinking
I think
about...
we begin with average. I don't feel like it was all that hard.
Mhm. It's definitely tricky to think about the consequences of, like, the long-term, like, the distance that you have to go. And thinking about how these ones operate. I mean, maybe we were just sort of slow thinking through the possibilities. I don't know. I does not know. Average is fine with me. I think it's on the tougher side of average. Even if most people are rating that as a 2-star. But yeah. All right.
What was that
Anything
about? At
else?
least a 3 start? Oh,
Yeah.
okay. A harder, an average start. Tough start, subsequently very smooth.
Yeah.
Yeah.
Which, for me, I think the it getting easier at the end is not necessarily an indication that it's a easier puzzle because the ending was easy. The difficulty of the puzzle is the difficulty of the hardest part of the puzzle. And I guess maybe there is some argument that if there is like a lot of difficult stuff, even if individually, it like if there were like 4 average things to do, that might be considered a hard puzzle because you have to do so many things that are of average difficulty. But I guess it really depends on the subjective nature of determining the difficulty of a puzzle. So I don't know. I'm fine with average, so I rated it. Yeah. Anything else to say?
I liked it.
All right, then our next puzzle is going to be Chess and Checkers by LJC. I have put the puzzle link in the chat if you'd like to give it a go. But the rules are normal 6x6 Sudoku rules. Place the digits 1 through 6 once each in every row, column, and box. Knight's move. Cells separated by a knight's move must not contain the same digit. Little killer. Digits along a marked diagonal must sum to the given total. Alright. Well, okay then. We don't know what the given total is, we just know that it's x. And this one would be x plus 1, x plus 5, and then just 18. Now, I mean, the maximum here is a 6, a 5, a 6, a 5, and a 6, which would be 18 plus 10. So 10 degrees of freedom is a lot of degrees of freedom. And if I were to paint these, let's say I paint this one blue, those two red, this one yellow, and this one green, they don't even overlap that much. In fact, they don't overlap at all, otherwise the cells would be doubly painted. Now, I guess one thing to note is that whatever we make x, it cannot be part of the sum x plus 5 or x plus 1.
Right. Well, x cannot be 1.
Right. because the
cannot be
minimum here
2.
is 4. And the maximum, well, the theoretical maximum is 12 and 5, which is 17. However, this is x plus 5, which means the maximum is 11. So I don't know why I brought that up. Max is 11. This one's max 7. I mean, this is 4 through 7. And then this would be 8 through 7. Excuse me, 8 through 11.
Yeah.
I mean, I could just make it a 6 and a 1, 2. Well, no, that wouldn't work. Yeah, it would. No, it wouldn't. It would be a 5 and a 1, 2. Although I could just simply put 5 and then 2 digits that sum to x. And the same thing down here, just with the 1 and 2 digits that sum to x. Okay,
All right, well, where is red?
Yeah. One of those two, one of those two. And it's just that.
Well, okay, consider box 4. Where can red go in box 4?
One of these 4.
No. Can't be the upper right. It can't be the top 2 because of anti-night.
Oh, I completely forgot of anti-night. Then where is this digit in here? Well, this digit can't be one of those two or one of those two. So this digit is repeated on there.
Yeah. So,
Same is true of that one.
okay. So, green, if you double 1,
Would be 2.
right. So, plus 2 is 4. 3 is 5. Never mind. Can you double 2? That would be 4. Because 7's the max on that, right? Yeah.
Yeah. So it could go 1, 2, 3.
Right.
But since this goes to 11, it's 1 through 5.
Right.
Or, well, no, wait. It's minimum 8.
Well, 1 and 1 and 6.
Yeah. Which I don't know why I thought earlier about a 1, 2, and a 6. 1, 1, and 6 works. either of these two, rule out that one. So it's either this diagonal, or it's like this. Which is fine.
All right, we know where going from box 2, that blue.
Yeah.
And it's one of those two in box 4.
That's true.
Box 6.
Can't be that one. Or that one. Now the colors are no longer indicating the diagonal.
Right.
It's indicating a specific cell now. Now, one thing we don't know, we obviously know that red, blue, and yellow are different digits, but yellow and green don't have to be different.
Right.
Is there a way to prove that they're the same? Because, like, if we look at in box 1, we know that green can't be one of those three. So green is one of those. Now what about yellow? Where can yellow go? It can't be that one or that one. But I think that's it. It would have to be one of the three on the bottom. But that just rules out there. So that's not the right path. Because the same thing is true down here. Yellow has to be one of those three. But it can be lots of different things in here. Although I didn't consider what green could be in box 2. I mean, it can't go there. And it's not red. It could theoretically be blue. Except actually it can't be blue. Because if green and blue were the same, then one of these two would see both of those two. So blue would be ruled out of box 6. So we know green isn't blue. And it's not red. So it's just the question of, is it yellow? Because if they're the same, that's going to tell us stuff. But green has to be one of those three. I mean, I could say this one has to be one of those two. Which then means it has to be one of these two. Do blue and purple have to be the same? Because we know blue isn't green. So if that was blue, that would be blue. But if that one was blue, then it would be one of those two. What about purple? Do we know that purple isn't yellow? Yes, because of the same reason purple isn't, or green isn't blue. Because if purple and yellow were the same, then those two would be lined up and break. So purple has to be one of these, and both of these see that one, and that one. So purple has to be one of those three. And that one. Blue, purple.
Purple can't be bottom center because it sees all the
Oh,
ones in box.
yeah. That's going to be the same true of blue up here. Green and yellow can be any of those. Okay, well, if I ask the question of where is blue, that one and that one. And then the same thing should be true of purple. And green. Okay. All of this to try and prove that yellow and green are either the same or different, and blue and purple are either the same or different, which there's probably an easier way than what I'm doing, because this is chaotic. Okay. All right. Let's assume what is it I want to assume? That yellow and green are different. So this one was yellow. This one was green. If we assume they're different, then green has to be one of those two, and yellow one of those two. But just focusing on green. Green is one of these two, one of those two, these two, one of those three, one of these three. So if I pick this one, rules out those and that one, this one rules out that, this one rules out that one rules out that one. So then, where does yellow go? Oh, I didn't mark yellow in this one. Well, it has to be one of those two. Well, it has to be one of those three. And so that rules out this one. Okay. So, if this is green, then that one's green, that one's green, that one, and that one. And of course this one. 1, 2, 3, 4, 5, 6. Okay, so where would yellow go? Well, yellow would have to be, obviously this one, because that's given. That one, that one. White, red, blue, purple. Okay. So, if I say this one is green, then that makes this one green, that one yellow. Those two can't be green. So this one is. Then that one's not yellow. Those two being green. Those two is green. This one being green. This one green. So that one can't be yellow. Can't be green, so that's green. Yellow. And so here, that yellow makes it that one. And then those two are removed. And we get yellow. Okay, so it's possible. And then if I swap it to be this one is green, then those two aren't. That one is. This one isn't. Those two aren't. That one isn't. Okay, so if they're different, it looks like this. Or the other way that I had it before.
Right.
Okay. Okay, well, I proved that they could be different. How about I prove they can be the same? So if they're the same, then we have this pattern and that pattern, and we know that those two are the same. That's fine, because I either picked this one and that one, which makes those two, or I make those two and those two.
Right.
So they could be the same, they could be different, it doesn't matter. And YouTube's not getting enough. It's just bouncing up and down. Why am I dropping frames? OBS, stop dropping frames. I don't even know why. It keeps bouncing up and down around the 10 megabits per second. This has got to be on YouTube's side, then. That's so weird.
In the 18 killer, the blue has to double.
Yeah. I just have to double again. No, it doesn't. This blue could be purple. I almost wonder if I should just focus on, like, one column. Because we know where red is in both columns. So if I were to call this orange, purple, and black, then, I mean, red has to be one of those. Orange is taken out of those. Purple. Oh, I called something purple. Oh, I guess I'm just going to take purple out. Because I'm only putting that there because it mirrors the blue there. Well, black has to be one of those. Yellow can't bear. Did I use all 4 colors down here? Red, blue, yellow, orange. Well, red has to be on top. Blue has to be in this weird diagonal. And orange can't go here because it has to be... Wait, hold on. This is a blue-orange pair. That's yellow, and this one's red. So that's not red, and this is. And, well, that isn't yellow, so this one is. If let's take out black for a moment, and well, maybe not. Let's leave that for a moment. If I think about the same thing going on in this.
Okay, with what you've got now, you can place red in box 3.
Yeah, that's true. Red's here and here. That should be enough to know, to prove that this one's green. Because if I think about these, and I think about these two, well, this one has to be one of those two. Well, I know it's not red, so those two are the same.
Right.
Let's call that this form of gray for a moment. Well, where is gray in this box? Well, it's not red, it's not there, and it's not there, or there by anti-night. So that one's gray, and this one's green. 1, 2, and 3. Well, now I know that green and yellow aren't the same.
Yeah.
So, well, where's green in here? It's none of those, and it's not blue or orange. We know it's not red, so purple is green.
Well, look where green goes in box 1.
Because I know purple wasn't one of those two, and it wasn't one of those two, and purple isn't red, so that's green. So that one's not green, that one's not green, so this one is. And of course, green also goes here.
Now gray is blue or black.
Right. Well, no, it can't be blue or black.
Well, it's not green. Oh, it can't. Right, it can't be blue or black. Therefore, it's yellow. It can't be green, red, or orange.
Okay, so what are the remaining digits? Blue, orange, and black?
Yeah.
Well, orange is out of here. And blue is out of that one. And black is out of that one.
Okay, box 3, top right. Oh, no, never mind. That was a mistake. I was going to say can't be blue or black, but yes, it can.
Yeah. It's just, it has to be one of those two.
Right.
Torak says that I can start solving now. Hi, Torak. How are you doing? I've been trying to solve it for the whole time, but I guess we know that so I think you're talking about no, I want to have all of the coloring done. Of course YouTube's gonna have all of the rest, but all right, Tulrex says no more coloring, it's not allowed. Okay. Let's see. Well, x plus 5 is 2 yellows plus green. and x plus 1 is 2 greens plus yellow. Does that mean that green cannot be a 3? Because that would be 6 plus 1 for 7. And 3 plus 2 for 5. Yeah, so green can't be a 3. Could green be 2? That would be 4 plus 1, 2, or 3. Because my max is 7. Although, unfortunately, I can't keep those numbers in my head. But I guess... Wait, hold on. If this is a 2, and those are 1, 2, and 3, then, yellow, couldn't be a 1, because 2 and 2 is 4, but I need to have x plus 5. I need to get to at least... at least 8. So if this is a 2, those would have to be 3s. Because if these are 2s, then this is maximum 3, and that would be minimum 3 with the 2. And so if these were 1s, then that's a 1, and I need to get to a minimum 8, so then these would have to be 4s, or 5s. So that would be 4 or 5, which is allowed. So yellow isn't 1 or 2, it's 3, 4, or 5. So what did that mean for red? Well, 1 and 1 is 2, plus 4 is 6, minus 1 is 5. Because if it's 2, then I have to have I had to have 3. Wait, if this was a pair of 2s, that would be 6. Excuse me. If this is a pair of 2s, that's 4. To a maximum of 7 would be 3. And if that's a 2, I am really bad at this. I'm a math tutor.
If you look at x plus 5, that's going to be either 10 or 11. So if it's 10, green has to be 2, and yellow is 4. But that would make the reverse 8. Double 2 and 4, which does not work. So if x is 6, that's 11. So green has to be 1 and yellow is 5, which makes 5 plus 2 1s is 7, is what you've got. Did you listen to any of that I said?
Got a plus 4.
Green does not equal yellow.
Yeah, we proved that a long time ago. Make sure this is all on the screen. Hoot.
We know that x is either 5 or 6.
Right.
So x plus 5 is either going to be 10 or 11.
Right.
If x plus 5 is 10, green is even in 2, and yellow has to be 4.
Yeah.
But to do the 2 greens and 1 yellow makes that 8, which is too big for x plus 1. Therefore, x plus 5 has to be 11, green is 1, yellow is 5.
So this has to be... We have to maximize this
Right.
to get 18.
3 and 4 is 7. 7 and 7 is 14, and 4 is 18. Blue is 4.
So orange can't be on here because orange is 2. 4, 2, 3, 4, 3. That's not black. That's not orange. This one isn't black. Those two aren't orange. This one isn't blue, so those two aren't black. That one's not orange, so that one's blue. This one's not blue, so that one's black. 3, 2, 4. Okay. Alright, and I missed Miranda Estrada saying hi. Hi, Miranda. How are you doing today? And then Turek, I appreciate the help with the yellows and the greens. Yeah. Alright. Trying to think if I have anything else to say about the puzzle. Although you couldn't finish coloring before the 18 diagonal, that's why I forbid you from coloring further. I appreciate that. It did make sense. Yeah. Logic Masters Germany. That's where I'm trying to get. My brain short-circuited. Chess and checkers. I wonder why it's called chess and checkers. Paste. No matches. LJC maybe? Nope. Alright. Not on Logic Masters Germany, as far as I can tell. Why is my phone being weird? Okay, my phone's being weird because YouTube was dropping connections. But I think we're
I was being weird?
fine now. No, YouTube.
Oh, I thought you said
my
Mum was
phone.
being weird.
No, I apologize. I will try to speak more clearly. Now, I was going to jokingly say you were probably being weird anyway, just because we're weird people. But I don't know if people would understand the joke, or if you would necessarily appreciate the joke.
I don't care. I'm weird.
Okay. Close out of that. Don't save.
Normalcy is overrated.
Yeah. I was pretty sure you would appreciate the joke, but I didn't have like anything like specific to point it at, so alright. I have said as much as I could about that puzzle, and now my hips hurt. So I should probably sit in a chair properly. I've never done that before, but first time for everything, you know? Okay. Why is my brain like not functioning properly? Whatever. I will figure
Are
it
you
out.
overtired?
I mean, it's possible. It did take a while to get to sleep, and it's late-ish, but I don't know. All right, I'm ready for one more puzzle. My phone is working properly. Everything's working properly. Okay, so I think we're situated now. One more puzzle. Hopefully, we can get it done before too late. Yin Yang Counting Circles by Dag H. Normal Sudoku rules apply. Yin Yang. Color the entire grid in 2 different colors so that A, each color constitutes one orthogonally contiguous region, and B, no 2x2 square of cells is entirely one color. Counting circles. A digit in a circle indicates how many times that digit appears in circles. All odd digits in circles are one color. All even digits in circles are the other color, and white dots separate consecutive digits of opposite color. Okay. Okay. So we just need to paint odds and evens. My brain didn't understand the rules.
Looks like 21 circles.
Copy, paste this over here, and give everyone a link to the puzzle if they'd like. Alright. Color the entire grid in 2 different colors so that A, each color constitutes one orthogonally contiguous region, and B, no 2x2 squares. Counting circles. You said there were 21 circles. All odd digits are one color, all even, and the other separate consecutive digits of opposite color. Okay. Well, these two are the same.
At least 4 different numbers.
Yeah. And so this must also be that. So this one's the other. And it has to be contiguous. But I don't have to make both of those yellow. But I also couldn't make it. So I know that these are not all purple if I were to make these both yellow. So one of these is yellow, the other is purple. I guess also I know one of them is yellow-purple there. So this one must be purple, since that's where the other yellow is.
Well, and yellow has to continue.
Yeah, but it doesn't have to continue with both directions. In fact, it can't because the yellow is here, and we know that the coloring is fixed between the two odds and evens, between odds and evens.
Right.
So we know that there is 5 yellow, either 4 or 5 yellows. Well, actually, wait, hold on. We know these aren't both purple, so one of them is yellow, and because of the dot, we know that there's a yellow on the dot. So there are 5 yellows. Yellow is odd. And odds are orange, and purple becomes grieved. Hopefully no one is groaning too bad at that pun. But, maybe they'll get over it. Alright. That wasn't the most funny way to deliver that joke. I will have to work on that one.
The fact that 21 is in there are column 2 has 6 circles.
Oh, that has to be 1 through 6 then.
Yep. Row 2 has 6 circles.
Oh, that gives me the 1. So that 1 must exist in both columns. 3, 4, 5, 6. And actually, the 2s have to be in the rows. This is going to have to be a 6. I think. Could be wrong. Because this is where my 3 is. So the 3 is going to get removed from everything else. And so I've got... Well, that's another 4. And this is another 4. Plus the 4 that's in these two... Oh, wait, not guaranteed. And actually, I could have a 3 in one of those two. That one can't be a 3. And then everything else is removed from being a 3. Now, I have 1 4 guaranteed, a second 4 guaranteed, a third 4, and a fifth 4. I just said that there are 5 4s. Right after the 3 4s. Apparently 4 4s is what's allowed. Oh... Maybe I am overtired.
So the first cell of box 1 can't be a 4. And its property dot can't be a 3.
Okay. 1 5, 2 5s, 3 5s, 4 5s.
Oh. And if the purples in box 1 are all odd, are those all the same?
Oh, yeah. Well, one of those has to be even.
But if those are
But
all
if those
odd,
were both even, right. These cannot both be odd. But I painted them purple because they were the thingies.
Oh, right. You were counting the...
Yeah. I wasn't doing odd and evenness.
So then, is there a reason that the purple to the left...
Because it's in the row. 2? I was counting 1 5, 2 5, 3 5, 4 5. But I can take
is
the
there a
purples
reason
out.
but that the circle to the left of the 1 can't be a 2? Because it's in the row.
Oh, right. Yeah.
And the same with the 1 in the column above the 1?
Well, it can't be a 2 because of the 5 6 consecutiveness.
Right, okay.
But I took it out too early. If this is even, that's even. Well, I just know that these two are the same. So whatever those two are, they're the same. And make them, I guess it doesn't really matter. Make that one purple.
Well, the blank spots in rows 1 and rows and column 2, row 2 and column 2, the blank spots are 7, 8, 9. That's what I'm trying to say. So that has to be an 8, 9 pair.
Four, 5, 6 triple.
And the cropty dot in column 3?
Column 3.
Cannot be an 8, 9 pair or it would break.
Well, it can't be a 7 because that has to have a 7 on it. Well, if that has to have a 7, that can't be a 7, so that is. And it's odd.
Row 7 in box 9. That's a 1, 2 pair.
3, 4, 5, 6, 7, 8, 9. 7, 8, 9. 3, 4, 5, and 6. Yeah. These two had to be the same. I took a 4 out of this one. No, those two are the same, and that one is different. Okay, and because of the contiguous, everything's contiguous, I either wrap around this one or wrap around this one, so this one is also purple. Although this purple and that purple aren't necessarily the same. Well, okay. I know this is even, so 3 and 5 are gone. I know this is odd, so 2, 4, and 6 are gone. 1, 3, 5, or 7. Oh, well, the yellow. Well, we don't know that yellow's even, so. If yellow's odd, then it goes that way and it's just fine. I guess we know that 7 is one of these two. Not that it really matters. 1, 2, 3, 4 5s. And 4 6s. So we just know that these, there are 2 6s and 1 5. So that means that this cannot be a 6, because it would rule it out of 2 of them. This can't be a 6, it would rule it out of 2 of them. So I have to think about how the odd digits and the odd and evenness are going to propagate around the grid, I think, is the sort of the concept.
Okay.
Uh-huh.
If yellow in box 1 is odd,
Yeah.
then that's already 4 odds in column 1.
And I will only be allowed one more.
Right. So at least 2
Of these three.
of those are even.
So that means purple can't be
So
even.
purple cannot be even. Yeah, that's what I was trying to make sure I was thinking right.
3 and 5. So 3 is required there. Okay, and no 2x2s, so that's green.
So only 2 are green.
Oh, wait.
2 of those are even.
Wait. I think we're getting ahead.
Oh, right. That's if those were both odd.
Yeah. Gosh darn it.
Trying to rule out that they could be odd. But apparently that...
Yeah. Well, I mean, if that's odd and that's odd. No. Yes. If that's odd, that's odd. And that would be even. One more odd would be in here.
Look at column 2 now.
Uh-huh.
If that's all odd in box 2, 3, 4.
No, that's even. That's even.
That's
one of those
even.
two is odd.
Yeah, that didn't make any difference. Even odd, even odd, even odd. That's 1, 2, 3. 1. Oh, yeah, look at column 2. Okay. The 2 Kropke dots are even odd pairs.
Yeah. 3 odds, a fourth odd, and the 8, 9 is the fifth odd. So these two
are even.
Even is green, because green is greven. And then that is odd. So this is odd. So then this goes back to being greven. 3, 5, 2, 4, and 6. And
The 5, 6
no
is
2x2s.
resolved because of the even odd in box 1.
Right. 5. And there was only one 5 between these three. So then these two are 6. And that's a 6.
Yeah, going back to box 1, that last circle is odd.
2, 4, 6. It's a 3, a 2, 2, 3, 2, 3. 5's required. 4, 3. Even. Odd. Not a 4, not a 6. This odd must escape. And this cannot be odd, because then the evens would have to envelop this in order to connect, and then this odd would be separated, because all color the entire grid in 2 different colors so that A, each color constitutes one orthogonally contiguous region, and B, no 2x2 square of cells is entirely one color. And we know that both sides touch all the walls. Both colors touch all the walls. So, math. But this has to be even, so it's an 8. And this is an odd 9. But then I get the checkerboard there. So, do I not need to care about the checkerboards yet? I mean, it's... Or did I do something wrong? Okay, if I go back on the checkerboard thing, this would still have to be this way. It's just I don't know how that operates. If I ignore the checkerboard part. Although I'm not... Color the entire grid in 2 different colors so that A, each color constitutes one orthogonally contiguous region, and B, no 2x2 square of cells is entirely one color. Is that even possible? I mean, it has to be possible because this puzzle has solves, but at least I'm assuming it does. But on this wall, I'm going to have some green. And if that green is going to connect to this, then it is going to have to go around this orange. And let's say it connects like that. Well, then this isn't going to be able to be... This isn't going to work. And it doesn't matter how I loop around. It's going to be isolated. So that this cannot be odd, because if it was, these odds would be isolated from the rest of the rest of the odds. I misread the rules. Gosh darn it. All odd digits in circles are one color. All even digits in circles are the other color. White dots separate consecutive digits of opposite color.
Oh, they're not... Oh, yeah, they're still consecutive.
Yeah. Okay, well then I shouldn't try and paint them. Did I mess things up? Okay, because I was operating under completely different rules. 2, 3, 4, 5, 6. 1. And then, well, 1 and 2 is already taken up, so 3, 4, 5, 6. So there's my third 3. So the rest, well, this has to be 4, 5, 6. So there's my fourth 4. So the rest look like 5 and 6. 5 and 6 has to go down to a 4, 5, 6. And now we know that 1 is odd, and I guess I'm just going to make it red. And now one of those is red and the other is blue. Now, it is still true that whatever color this is, those two are the opposite color, and therefore this is the same color. So these are opposite digits. Those are opposite digits. But the odd and evenness is no longer a thing. I'm upsetty spaghetti.
But
Purple,
it can still give
yellow.
us... I mean, row 2 and column 2 still have the 7, 8, 9s, and the 1, 2 pair in box 9 still applies. Yeah,
This
that's a
cannot be
7,
an 8,
8
9.
pair. All right, 6, 7, 8.
And this one isn't a 6. Now, 7's required, so the 7's that are there, 8, 9 pair still makes that a 7, but because it's odd and not in a circle, it doesn't tell us the color.
But it does still tell us in column 2, because the Kropke dots are still even odd pairs. And the 8, 9 is an even odd pair.
One, 2, 3, 4, 5.
And the 7. So that's still even.
But because
And
I
even
made
is
odds
still
red, so this is blue, so then these are still red, because this couldn't be blue and lock that out. And now
Right.
because it's in a circle, it is now odd. So this is still a 5. 2, 4, and 6, this is still a 3. Those can no longer have a 2 in them, so a 5 is required, so 5's out of there. Purple, yellow. Blue must escape. Okay, and this still has to be purple, whatever it is, because the 2 by the fact that the yin yang puzzle, if I were to make this yellow and I make this one also yellow, no matter how much I try to avoid locking out this purple can no longer reach this one. If I were to make all of that yellow, then those two are locked away from each other, which I know is not allowed. So this must be purple. Oh, this is a 5, so these are both 6s. Is that a 6? And this a 2. Not a 6. Not a 6. Three, 4, 5. So this is 4 because 3 and 5. 4 is out, so this is either 5, 6 or 2, 3. Okay. Well, this couldn't be a 5, because then it would have to have a 4 next to it. And it can't be a 3 for the same reason. So then 2 and 6 isn't allowed. And then because this is even, and evens are blue, if it's a 2, it pairs with 3 and 1, and a 6 would pair with 5 and 7. Now, this whole wall has to be red. And the reason for that is, let's say I make this one blue, right? It's the farthest away from this blue here. And let's do our best to keep to connect these two without cutting off the reds over here. Well, I could go all the way around and connect those two, but then these reds need a space to escape. So what if I just did this? Well, now those reds need a place to escape. There's no way to connect these two together without separating reds from here or here. It's just not possible to create that, because however I go about it, right, I have to draw a line like this, which I can create more space this way, but it doesn't stop the fact that this is a wall that I'm just moving out. This is still locked out over on this side. So everything on this wall is red. And, well, because these two are separate, well, I don't know that the rest of this wall is blue until I find a blue. So everything is blue until it's not blue. But then once I find that red, then I think it has to go all the way around. And so we have red on this side until it's not, and then they will connect like that. Hopefully that made some sense. And now, no 2x2s. Okay. Oh, these 6s and the 2 are blue, because evens are blue. Evens in circles, and only in circles, are blue. And then the dots separate digits, or rather squares, that are different colors. Can this be a 3 and a 4? I think the answer to that question is no. Because if it was 3, 4, then this would have to be 2, which would pair with a 3. So that's why it can't be. But it could be 4, 5, which would make this 2, 3, and 6. We'd have a 4 or 5 pair there. Okay. And now we're past time. Purple, yellow, no checkerboards.
Circle in box 2 is even.
Oh, yeah, that's blue. This 3-5 is odd, so it's red. No checkerboards. So whatever this one is, it's not that one. Because this is close to another one, I'm going to say orange and black. Oh. Well, because these are different. These two can't be the same. It would create a checkerboard.
Well, it only the two colors only matter even and odd in the circles.
Well, even oddness, but the circles, the all odd digits, or excuse me, white dots separate consecutive digits of opposite color. So the circle, or the crocky dots, the white dots, separate colors. So because of that, if this was even, or no, if this was blue, that would be blue, and then that would be red, and that's a checkerboard, which isn't allowed. So this is red, and then these two are blue. And no 2x2s, so now the rest of this must be red. No checkerboards, so that's blue. No 2x2s, so that's red. And we have to go all the way around being red.
Right.
And because... Go ahead, sorry.
Which makes that bottom, that red circle in box 9, a 3-5.
Yeah, so the reason we had to go all the way around the grid is if I were to put a blue anywhere, right? If I just back up for a second. So learning that this was red, right? And it has to escape, so that has to be another red. But let's say I put a blue here. Well, this blue will then have to connect to this group. It's also blue. Connect to this group. So if in order to avoid trapping this red, I can go like super far around, but it's gonna trap this red anyway, right? No matter how do I connect to this blue. So I have to go to red all the way over to here. But it's not isolated to a blue there, right? Any of these, if I were to make this blue, well, it has to connect over here. And no matter how I go about doing that, right, the reds that are over here are going to be separated. So all of this must be red. Red, purple, yellow, blue. No 2x2s. Checkerboards, no checkerboards, no 2x2s, no 2x2s. 5, 3, 5, 3, 5, 4, 6, 4. This one's blue. That's 2, which makes that 1 and 3. 2 and 3. 5s, but we already knew that. That's a 5, that's a 3, that's a 5. No checkerboards, so this is blue. No 2x2s, so that's red. No checkerboards, so that's red. Blue must escape. Apparently that's a 6.
Yellow circle in box 4 can't be a 5, because then to the right it would have to be either 4 or 6, and that doesn't work with the row.
Oh, right. So that's a 4, and then a 5 and a 3. 4. And blue. And purple becomes red. 6, not 6, 7, 8 makes that 9 and 8. And 9. No 2x2s. No 2x2s. No checkerboards.
No
Red
2
must
by
escape.
2s come down column 6.
2x2s. If this was red, this blue region wouldn't necessarily be locked out. Never mind. Okay, are all of the circles painted? I think so.
Mm-hmm.
Okay.
Yes.
If this was red, that would be blue. If this was blue, that would be red. I don't see a problem with either way. Five, 6, 7. 5, 6, 7 pair. 1, 2, and 4. 1. 3, 8, 9. 7.
Column
Not
6,
7.
box 5. If that white is red, then the blue above it is locked out. Oh no, that can go down there. Never mind. But that red would be locked out then.
Oh, yeah, that's true. Yeah, because it doesn't matter what color this is. This red needs to escape. So this is red. And then no 2x2s. And now this must escape. So blue. No 2x2s. No checkerboards. No 2x2s. No 2x2s. No checkerboards.
That red in
Red
box
must
5
escape.
has to escape.
Must escape. Must be the opposite color. And must connect. Or escape. Okay. And 2 and 4, 2 and 4, 6, 7, and 8, 9. 1, 2, yes. 6, 7, 8. 2, 3, 7, 8, 9. Those aren't 3s, those aren't 7s. 1, 2, and 7. And it's not super helpful. 3, 8, 9, and 7. So 7 is one of those two because it couldn't go here because of that 7, so that's not a 7. 8, 9 pair makes that 7 and 8, so that's not an 8. One, 2, 3, 6, 7, 8, 9. 6 isn't on top, that's not a 3, that's not a 7. This is way more restricted. 2, 8, and 9. And then these two. aren't 6. That's not a 3. That's not a 7. 1 and 2 can't connect, and 3 doesn't connect. So that's a 6, that's a 7, this is an 8. Not a 7, 7, 8, not a 7. These aren't 8, so that's 9 and 8. Those aren't 8s, these aren't 9s. This is apparently a 3, a 1. 1 is out, 3 is out. 4 and 5. Well, that's not a 5. But I guess it has to be a 4 or 5. I don't know why I have a driver, but I can't update that because I'm using that right now. 7, 8, 9, and a 1. So that's not a 7. 9, 8, 2, 4, 9, 2, 9. That's a 7. That's not. 2, 1, 9, 8, 2, 2, 8, 2.
Row 4 ends with a 2.
So 1, 7, 1, 7, 1, not 1. 2, 3, 8, 9, okay. 3, 8, 9 makes a 1. I guess 8, 9 pair made a 1. 3, 9, and a
7.
7. So 3, 7, 9, 8, 9. 2, 3, 8, 3, 9, 1, 2, 8, and 3. Need a 1.
A 9.
4, 9, and 5. First try. Alright. If I would learn to read the rules and understand them, I only read the rules like 3 times. And still didn't grasp that it was only the odd digits and circles. Yeah, I was definitely overtired. I got thrown off my groove at the end of the last puzzle. I don't know how. And I just couldn't get back. So, I need to eventually figure out, like, the signs that I'm tired and my brain doesn't work. Because, I guess I literally couldn't tell, except for the fact that my brain was just sort of like, Robert.exe has stopped responding. But yeah. Anyway, let's see if we can find this puzzle. I just realized I haven't been putting the puzzles in my notes. I'm sad.
You have the links in the chat, so.
Yeah, and I also have a history, so, yeah, I'll just grab those real quick. History, so that would be Comnos, that's not that. History, this one, and then we'll just click on this one, and then doot. Copy. Oh, yeah. It is the time of nap. So, everyone, thank you so much for watching. Make sure to like, comment, subscribe, all that fancy YouTube engagement stuff. If you're interested in more content on this channel, that is Sudoku, Mondays and Tuesdays at 8 p.m. Eastern Time. If you are interested in gaming content, on Saturdays, I've been playing Monster Hunter World with a friend of mine. And, I've also been randomly playing Final Fantasy VI. Make sure to ring the notification bell if you want to be notified. Aside from that, it's always nice if you share the videos with your friends. And with that, I'm going to go ahead and switch over to the stream end scene. Thank you so much for watching. Have a wonderful day.